All right, moving on with some more data structures in Python. Another thing is the tuple. And tuples are very much like lists. The only real difference, though, is that they are what we call immutable. So that means that once you declare a tuple, you can't change it. And these are useful in functional programming approaches and things like that, so you do see them crop up once in a while. The only real difference syntactically is that instead of square brackets, you use parentheses to indicate a tuple. And again, that just means that it's an immutable list. So we can create a tuple just like we would with a list, just with parentheses instead of square brackets. And it also has a length operator, a len operator, that we can use to get back the number of elements in that tuple. Let's try it out. Sure enough, the tuple that contains the values 1, 2, and 3 has 3 elements in it. Let's set up another tuple that contains 4, 5, and 6, and you can see we can read back from it in just the same way that we would have from a list. Y bracket 2 gives us back the third element of the tuple, because again, we start counting from 0, remember? So that gives us back the value 6. And just like you can have a list of lists, you can also have a list of tuples. You can mix and match these things if you want to. We can define a list of tuples by having a list operator here with a square brackets that contains the x and y tuples. And you print that out, and you can see that we have a list indicated by the square brackets that contains 2 tuples indicated by the parentheses. So we have a list of 2 tuples, the x tuple 1, 2, 3, and the y tuple 4, 5, 6. All right. Now, something that you often see tuples used for is with the split operator here. So I'm just using this as sort of an example of tuples in the real world. One thing you can do is use it as a convenient way of assigning the values that come back from an operation like split into a set of named variables automatically. So here we have a string that contains 32, 120,000. And we can use the split command on that string to actually split that based on the comma character. And that should give us back an array that contains the value 32 and 120,000. We can take back the 2 elements of that get returned there and put them automatically into this tuple that contains age and income. So what this is going to do is give us back 32 and 120,000 and assign them into the age variable and the income variable for us automatically. We can then print out age and print out income to see if it works. And sure enough, we get back an age of 32 and an income of 120,000. Just by using that tuple operator to assign automatically these 2 variables to those 2 return variables there. This is probably a good time to point out that you don't have to declare variables in advance in Python as well. So we didn't actually declare what type age and income were as variables. It just sort of happened automatically. Python is what's called a dynamically typed language, so it automatically tries to guess at what sort of type a variable is when you first use it, a string or an integer or a floating point number. But once it has a concept of what it thinks that type is, it does stick with it. So it's not only dynamically typed, but it's strongly typed as well. It's not going to automatically change types for you behind your back. If you do need to change things from, say, a string to an integer, you would have to do that explicitly in your code. Moving on, let's talk about dictionaries. Dictionaries in other languages are often called a map or a hash table. And it's just a lookup table, really, so you can actually map some value to some other set of values. Let's take a look at an example here to make more sense. We can declare a dictionary with the curly brackets here. So we can say captains equals 2 empty curly brackets. That defines an empty dictionary called captains. And now we can set up this dictionary to actually map ship names to captain names. And if you're a Star Trek fan, you'll understand these references. I can say, for example, captains Enterprise equals Kirk. So the syntax here is captains followed by square brackets refers to some key in that dictionary. So we're going to say that the Enterprise key is mapped to the value Kirk. And the captains with the key of Enterprise D is mapped to the value Picard. For Deep Space Nine, it's Cisco, and for Voyager, it's Janeway. So now I have this handy dictionary where I can quickly look up the captain for a given ship. So you can see how that might be useful. If I want to look up the captain of the Voyager ship, I can just say print captains, square brackets, quote, Voyager, and that will look up the value of the captain associated with the key Voyager. And sure enough, that comes back with Janeway. An alternate syntax, instead of just using that square bracket syntax, is to use the get operation on this dictionary. You can say captains.get Enterprise to get back the value Kirk. And the reason you might want to use that get operation instead of just the square brackets is because it lets you handle errors a little bit more easily. So let's say that I try to look up a ship that isn't in my dictionary at all, the NX-01. I get back the value none. So That lets me assign the result of that dictionary lookup to a variable, and I can check to see if that's none and deal with that explicitly. Whereas if I just use the square brackets, that's a little bit tougher to deal with. Now, if you are a Star Trek fan, you know the correct answer is Captain Archer, but, I don't want to get too geeky with you yet. You can also iterate through all the keys in a dictionary by using this syntax here. You can say for ship in captains, and that will go through every single entry in the dictionary and print out the key and assign that key to the value ship. So for ship in captains, we'll iterate through every key in the captain's dictionary and assign that to the variable ship. I can then print that out and say ship, and then use the plus operator to concatenate that ship string with the string :space, and then concatenate that again with the actual lookup of that ship within my dictionary. So what's going on here is we're going to go through every key, every ship name in my captain's dictionary, print out that key name, the ship itself, add in a :space, and then do a captain's ship to look up the actual captain for that ship. So that gives us back this handy dandy little thing here, Voyager: Janeway, Enterprise D: Picard, and so on and so forth. And you can see that that works as expected.